Måndag 21:30.
Planet Earth, 4.5 billion years old. A solid ball of rock weighing 6 trillion tons. We are on a quest to destroy it. Using cutting-edge physics and planetary science, we will explore what could destroy our planet completely. A black hole?
It might seem harmless, but its gravity is strong enough to destroy the entire planet Earth.
A collision with the sun?
And before you know it, the Earth is falling into a fiery plummet.
A huge antimatter bomb?
Poof, okay, at a huge annihilation.
A giant rock from space?
You wouldn't want to be standing here 50,000 years ago.
Or perhaps a swarm of self-replicating robots.
It's been a nightmare of sci-fi.
These ideas may sound like science fiction, but they're all grounded in proven scientific fact. Our planet is seriously tough. It has survived everything a hostile universe could throw at it for 4.5 billion years. Yet in the past few decades, we have developed technologies so powerful that some people fear we could literally destroy the Earth. It's time to find out if they're right. 6 top scientists are about to reveal what it would really take to destroy an entire planet. Our first candidate is a black hole, the greatest destructive force in the universe. A black hole is what's left when a giant star collapses in on itself. The result? Gravity so strong that nothing can escape, not even light. What makes something that small dangerous? Density. The closer you get to the core of an object, the greater its gravitational tug. Think of a black hole as Niagara Falls, and the water going over like space getting sucked in. This unfortunate kayaker has gotten too close. Just like a star getting too close to a black hole. Dr. Phil Plait, astronomer and author.
The water going over the lip of the waterfall is just like space itself falling into a black hole. If you're kayaking, no matter how fast you paddle, once you go over that lip, you're going down. That's the point of no return. And it's the same thing with a black hole. No matter how fast you try to get out, it's going to take you down.
The gravity in a black hole is fundamentally different from the gravity we experience in normal life. Normal gravity you can escape from, at least in theory. Cosmologist and golfer Professor Lawrence Krauss.
It's commonly said that what goes up must come down, but that's not always the case. For example, if I hit this golf ball here and I hit it well, it would go fairly far, but it would still come back down to Earth. If I hit it harder, it would go further and still come back down. But if I hit it with a speed of 5 miles per second, it would escape from the Earth's gravitational field.
But for the ball to escape from a black hole, it would have to move faster than the speed of light, and that is simply not possible. What goes into a black hole, planets, or even stars, never comes out. Our small planet wouldn't stand a chance. For anyone looking for a way to destroy the Earth, black holes are a good place to start. The trouble is, there are none close by enough to do the job. Unless we make one. That's where the Atom Smashers come in. With a lot of math and a gigantic machine, physicists can now generate atom-sized explosions that may be powerful enough to create microscopic black holes. It all happens here in Europe, underground near the French-Swiss border. Scientists at CERN accelerate subatomic particles along a tube, then smash them together at close to the speed of light. They are trying to study the Big Bang. The force of the impacts recreates the particles that made up the universe in its earliest moments. Some of those particles may create microscopic black holes. That doesn't mean our planet is doomed. In theory, black holes this small would just evaporate like tiny soap bubbles. To destroy this, you need something bigger.
Black holes come in all sorts of different sizes. For example, at the center of our galaxy, there's a black hole of 1 million solar masses. If you took the mass of our sun and compressed it down to be a black hole, it would be the size of a large American city like Phoenix here. On the other hand, if you took something like this mountain here, which is maybe 1 million tons, and made it a black hole, it would be smaller than the size of a single atomic nucleus.
Somewhere along that scale, black holes get powerful enough to cause serious damage. To destroy the Earth, it turns out you need a black hole that weighs about the same as the Earth. The Earth is 8,000 miles across. But a black hole weighing that much would be the size of a marble. Professor Clifford Johnson, physicist.
Here I have a marble-sized black hole. It might seem harmless, but its gravity is strong enough to destroy the entire planet Earth. What would eventually happen is that it'll start sucking things in, slowly at first, and then it will grow in size. It will grow and grow and grow until it swallows the whole Earth.
To imagine what that marble would do to the Earth, picture what it does to a physicist.
The gravity is much stronger on one side of an object closer to the black hole than it is on the other side of an object, producing an effect that's called spaghettification, as that object is stretched out and pulled apart as it falls into the black hole.
A big enough black hole could do this to our whole planet. There's no way even the most powerful atom smasher could make a black hole this big. To destroy the Earth, we need to find one ready-made. Astronomers think there are 10 million or so black holes in our galaxy. If one of them strayed into our neighborhood, it could rip our planet to pieces. Earthbound telescopes may not even detect it. Humans would only know it was approaching when its immense gravity triggers huge floods and earthquakes. As it plunges into our atmosphere, the black hole acts like a vacuum cleaner, sucking with a force over 1,500 times Earth's gravity. Then it begins to distort the shape of the whole planet. Earth's surface stretches and tears apart. Finally, the hole hits and flies straight on in, heating and vaporizing matter as it goes. It starts to orbit the Earth, inside the planet itself, all the time devouring everything in its path. Gradually, the orbit slows. The black hole spirals down into the Earth's core. Eventually, it eats the entire planet. All that's left is the black hole itself. It's a devastating end for planet Earth. But fortunately for us, it's unlikely ever to happen. So, if black holes don't work, time for a new approach.
The Border. Tisdag 21:30.
Tänk om man kunde få metaller att göra precis vad man vill. Då skulle man kunna bygga bilar som är lättare och styvare. Som skulle dra mindre bränsle och bli roligare att köra. Det gör vi på Audi. Upplev nya Audi A6. En stark lättviktskonstruktion.
Han återuppstod på en söndag. Han föddes på en söndag. Det var söndag då slaget stod. Det var en söndag då de landade. Och det grundades på en söndag. National Geographic fortsätter än idag att bygga historia på söndagar. Med de mest fängslande berättelserna och de mest fantastiska bilderna. Prisbelönt filmskapande. Från världens alla 4 hörn. National Geographic Channels bästa dokumentärer. The National Geographic Sunday Specials. Söndagar från 20:30. 0-100 på 3,7 sekunder. Toppfart 315 kilometer i timmen. Pris $183 000. Mega Factories tittar under huven på en bil med wow-faktor, Mercedes SLS AMG. Hur gör man för att bygga en bil som har blivit en ikon inom bilindustrin? Mega Factories, Mercedes. Torsdag 22:30.
They are modern-day miracles of construction and incredible feats of engineering. Take an eye-popping look at some of the greatest structures from around the planet. Architects, engineers, and builders come together with pioneering technology to show the whole world that the impossible can be built. We have exclusive access to the cutting edge of construction. Megastructures on National Geographic Channel.
One surefire way to destroy the Earth is to change its distance from the sun. Move the planet closer and it bakes. Move it out and we freeze, sending us into another ice age. Scientists have recently begun to realize that moving a whole planet might actually be possible. In fact, we use the same principle to slingshot space probes round the solar system. Planet Earth could be just a few well-placed flybys away from a fiery death. What would it take to incinerate an entire planet? Answer: a nuclear furnace nearly 1 million miles across. It sounds crazy, but the truth is this will happen. It's just a matter of time.
As the sun gets older and older, it's going to actually get brighter and brighter. And within about 2 billion years, the Earth will be in an uninhabitable zone. It'll be like Venus. There'll be a runaway greenhouse effect. All the water on Earth will be destroyed, and the surface temperature will be about 1,000 degrees.
Eventually, the sun will swell and scorch the Earth, unless we somehow move the Earth away from the sun to save it.
Alternatively, if you were sufficiently evil, I suppose, you could imagine doing exactly the opposite. Harnessing sufficiently large objects to transfer gravitational energy to kick the Earth's orbit closer to the sun.
Easy to say, not so easy to do. The Earth weighs in at 6 trillion tons. Pushing something that big is quite a challenge. But there is a way. It's called gravity assist. Space probe engineers use gravity assists all the time. Take Saturn's Cassini-Huygens probe. It's the size of a school bus, one of the biggest probes ever built. To build up enough speed to fling the probe out to Saturn, it had to swing by Venus twice and Earth once. Each flyby stole energy from the planet and added it to the probe. The probe got a lot faster by altering the planet's course just a little.
The name of the game here is energy, orbital energy. There's energy in the Earth's motion. So as the Earth's orbiting the sun, if we can steal that energy away, it'll fall in toward the sun. And we can do that using an asteroid. We take a rock about 1 mile or 2 across, and we move it so that it just passes the Earth the right way, and it'll steal energy away from the Earth. The asteroid will go flying off, and the Earth will move in toward the sun. But we shouldn't just waste the asteroid when we can recycle it. If we're clever, we can take the asteroid and have it go toward the planet Jupiter. And then if we pass Jupiter in just the right way, it'll take that extra energy it stole from the Earth, give it to Jupiter, and then fall back toward